Welcome to our video on free fall. We are now taking our study of motion from horizontal, meaning side to side, to vertical, up and down. An object is in free fall when it is only under the influence of the acceleration due to gravity or gravity itself. So when you throw a ball up and it comes back down, it's in free fall the moment it leaves your hand. So if here's your ball, right, you throw it up and it goes up and then it comes back down. The moment the ball leaves your hand, it's under only the influence of gravity, and this is called free fall. So objects moving upward and downward are both in free fall. When objects fall, they accelerate at a constant rate. This rate is called the acceleration due to gravity, and we use a little g. So this acceleration due to gravity is a change in velocity due to the effects of free fall. The value that we use is g is equal to 9.8 meters per second squared. This means that in free fall, all objects accelerate at the same rate. We are disregarding air resistance. When we solve problems in free fall, we will use our same kinematic equations, but now use them in terms of vertical motion. So for example, we had the equation the final velocity is equal to the initial velocity plus the acceleration times time. Vertically, this becomes the final velocity is equal to the initial velocity plus the acceleration due to gravity times time. So we've replaced A with G. This actually makes our problem solving a little bit easier because we'll always know the acceleration of an object in free fall. Our displacement equation, displacement is equal to the initial velocity times time plus 1/2 acceleration times time squared, can also be used vertically. So horizontal, we use an X. For vertical motion, we use a Y. So the vertical displacement is equal to the initial velocity times time plus 1/2 G instead of A, T squared. And then finally, the final velocity squared is equal to the initial velocity squared plus 2A, or G, we'll keep the A here, 2 times the acceleration times the horizontal displacement. This is now the final velocity squared is equal to the initial velocity squared plus 2G delta Y. So you will be given the same equations, the horizontal versions, and be expected to convert them into the equations for vertical motion on the right. So on any test or quiz or problem-solving activity, you're expected to write the equation on the right. So this blue dot is tracked at every 1 second. Again, this can be any object because all objects act at the same rate or accelerate at the same rate. So I invite you to try that now. Maybe pick up 2 different objects, maybe an eraser and a pen, drop them at the same time, and you'll notice that they land on your desk at the same time. So this blue dot can represent any object in free fall beginning from rest. So your initial velocity is 0 meters per second. The blue dot is mapped out at every 1 second. So as you can see, the object is falling a greater and greater distance with each second, meaning that it is accelerating. We use the variable delta y for vertical displacement or how far an object has dropped. So after 1 second, we can find how far any object would drop in free fall using the equation vertical displacement is equal to the initial velocity times time plus 1/2 gt squared. The initial velocity is 0, that crosses out. So after 1 second, the vertical displacement is equal to 1/2 negative 9.8 meters per second squared times the time squared 1 second. And this comes out to be negative 4.9 meters. So every object, the second after it's dropped in free fall, falls 4.9 meters. Notice that this is a negative 4.9 because we're falling down. We can do the same thing for 2 seconds and 3 seconds. We'll do one more. And this comes out to be negative 19.6 meters. So all objects dropped from rest and free fall will have fallen downward 19.6 meters after 2 seconds. Let's do a sample problem together. A ball is dropped from rest 30 meters above the ground. How long does it take the ball to reach the ground? What is the final velocity when it reaches the ground? I think for these ones, it's actually easier to draw our picture first. So here's our ball about to be released from rest with an initial velocity of 0 meters per second. We fall downward, that vertical displacement of 30 meters, and hit the ground. The ball had an acceleration of the acceleration due to gravity downward, and that takes a certain amount of time. So we list our knowns and our unknowns. We know the initial velocity is 0 meters per second. We know that the ball falls 30 meters, so we have a negative 30 meters. We have to read between the lines a little bit. The acceleration due to gravity isn't given, but this is a constant, always negative 9.8 meters per second squared. And we are looking for how long it takes to hit the ground and the final velocity. So let's solve for the time first. And we don't know the final velocity yet, so we should choose our equation that does not involve final velocity. Looking at your equations, you'll see the horizontal displacement is equal to the initial velocity times time plus 1/2 at squared. We'll rewrite this vertically and see that we have all of the variables we need to solve for time. So the initial velocity times time cancels. We're left with vertical displacement is equal to 1/2 gt squared. Going to multiply both sides by 2. Divide by g. And then take the square root to find t. We don't want t squared, we want t. So we're now ready to put our variables in. So we have 2 times negative 30 meters, because the displacement is downward, divided by negative 9.8 meters per second squared. So you should practice putting this in your calculator. This comes out to be 2.47 seconds. Remember, we're keeping 3 sig figs, so that's why I choose 2.47, not 2.5 and not 2.474. The problem next asks for the final velocity, and there are a few equations that we can choose, but one is easier than the others. So we can now say the final velocity is equal to the initial velocity plus the acceleration times time. So the final velocity, is equal to the initial velocity plus the acceleration due to gravity times time. Rewrite in terms of our vertical motion. It's already rearranged for us, so we're able to put our numbers in. Final velocity is equal to, the initial velocity is 0. So just acceleration due to gravity times time. Your final velocity comes out to be 24.2, negative 24.2 meters per second. And this negative makes sense because the object is falling downward. So again, objects can be dropped from rest or just falling down in general, and that's considered free fall. But objects can also be thrown upward. While they're moving upward, it's still considered free fall after an object leaves your hand. So I'm going to just draw this one a little bit bigger. So a ball starts in a person's hand, right, with some initial velocity. The ball will slow down as it moves upward, right, because we have a final velocity, or a positive velocity, and the acceleration due to gravity always acts downward. So when you throw an object up, you'll notice that it slows down on the way up. It will actually stop for a moment at the top. So the velocity at the maximum height is 0 meters per second, and then come back down. You'll also notice that either side of the ball's motion is symmetrical. So when we come back down, right, our velocity is negative because we're moving downward. The acceleration due to gravity is always downward. So this makes sense that when objects fall downward, they're speeding back up because their signs match. Okay. So the speed that an object is thrown is the same speed with which it will land if it's from the same height. So at each point, the speeds are the same, but the velocities are opposite because velocity includes direction. So we can say if this ball were to land back in her hand, that the initial velocity is just equal to the opposite of the final.